Hello everyone. Today we are going to solve a question from rotational motion, as you can see on your screen right now. And this is a little mathematical question, and this type usually do not appear in JEE, but I mean some questions like this may appear, and it has appeared seldom. So let's proceed with this. It says that a flywheel with the flywheel, you can think of an object, a wheel, any wheel, and anyway with initial angular velocity omega naught deaccelerates due to the forces whose moment is relative to the axis is proportional to the square root of the angular velocity. This means nothing but the torque this is proportional to the square root of angular velocity. Okay, and it's better to write a minus here because it's deaccelerating, and that's our base of the problem. And we can take that the initial angular velocity is omega naught. So anyway, that we will require later. Let's proceed with this. And now what we know about torque? Torque is nothing but I alpha, and let's write this as k root omega, where k is some constant. You know the rules of variations very well. And now what is this alpha? This is nothing but d omega dt. Okay, so wait a minute, we will write this proportionality constant in the next step. Let me write like this now. And now what is alpha? Alpha is basically d omega dt. So if we take I that side, I is also a constant. So from here we can write that d omega dt, this will be minus k into root omega, where omega k is the proportionality constant. Okay, so d omega divided by root omega, this will be basically your minus k dt. Okay, and now we will just let that the particle stops in time capital T, and yes, now we have to integrate this to find the final initial velocity, the final angular velocity is 0 and the initial is omega naught. So this gives you the limits, and for the time also you have the limits. This is 0 to capital T. Capital T is the whole time period of the object moving. And if you, this integration gives you what? This will give you basically minus 2 root omega naught, as root over 0 is nothing but 0, and this is minus kt. And from this thing, what you will get is the value of k. Okay, and this will be required in the further steps. So this is 2 root omega naught by t, and so let's write d omega dt. Let's write the alpha now, the deacceleration basically. So alpha hour is nothing but d omega dt, which was minus k into root over of omega. So this will be minus 2 into root over omega naught, omega divided by t. Okay, so we have our first part done. Now let's derive the general relationship between omega and t. Let's derive omega as a function of time. We need to derive omega as a function of time to solve this problem. And why do we need that? Because the average value of any variable, let x be a variable, okay, and one thing is important, that for this case x has to be any continuous variable. Okay, you know continuous and discrete, right? For discrete things are like 0, 1, 2, 3, And continuous is like from 0 to, I mean, all real numbers between 0 to some 9, 10, or maybe the whole real number set. This is continuous. Okay. So for a continuous variable x, we can write the average value as this xt dt, this divided by the whole time period. And for if x is discrete, let me write also that. I mean, I hope you know those things, but in case if you don't, let me just write this. So this is summation xi into ti. I mean, ti is the corresponding time to the xi. So I mean, just note these two formulas. You may need some time. Anyway, now let's proceed with our problem with ascertaining omega t. So we had that d omega divided by root over omega. This was your minus k dt. So now at any time t between 0 to capital T, we may write this integration omega to omega naught d omega divided by root omega. This will be k from integral from 0 to t dt. So this will be 2 root over omega minus root over omega naught, and in this side we will have into kt. K equal into 0 will become 0. So I mean, we only have that. And now the thing is, we have already derived k. We know the value of k, right? I told you earlier that is going to play an important part. So where did it go? This is the value of k. So just let's write it here. Okay, let's replace here and let's derive this omega. Anyway, so the 2 will be gone if we, I mean, k has a 2 term, so this will look something like this, and k was our root over omega naught divided by t. So, and also the minus will be, no, will the minus be gone or will it stay there? No, the minus will be gone. No, I'm very sorry, the minus will stay there because it's deaccelerating. So the minus has to stay there anyway. I mean, even if my mathematics is wrong somewhere, the minus has to stay. So this is root over omega naught divided by t into t. And okay, let me just once decrease the now it seems okay. So root over omega, this will become what? This will be omega naught divided by 1 divided by t by t. So as you can see, we have derived our omega as a function of time. I mean, we have to square this part obviously, but this will be this. And now we just calculate the average value with the formula I told you a little before in the video. That is nothing but, I mean, I am not writing the formula anymore. You can check it out from there. So anyway, so here will be 1 by t multiplied by the integral of 0 to capital T omega naught 1 minus t by t whole square dt. Okay, so now let's just integrate and we are done. So I mean, this is just simple integral. I have taken omega naught outside, so this will be t, and I mean, I am writing directly, you can check it for yourself. This will be t and this will be t. So, and this will be t squared dt. So this will be actually your t by 3. Okay, so if we cut all the t's, so we will finally get omega naught by 3, which is our final answer. So I mean, this was a very beautiful question. It was not too hard, but the thing is that you have to know this thing. If you do not know this average, I mean, what is the value of average over a time? So, and over the whole time of deacceleration they asked, so you have to consider from 0 to the capital T where the particle finally stops. So that's why the limit is so. I mean, that gives you the limit. So let me summarize the problem for you a little bit. So this was given to us. From this we wrote torque as I alpha, and then in the place of alpha we wrote d omega by dt, and we just calculated, integrated, and found out the value of the proportionality constant k. And after that we just calculated the value of omega as a function of time. So in this case, the limits, you can see that these are omega naught and 0. And in the second case, you can see that we have derived omega for a general time t. And this integration gives us omega as a function of time. I mean, this gives us the whole omega for any time between 0 to t. Okay. So that was the second step of the problem, and the third step was basically to calculate the average. And this was just basically an integration, just 2 lines calculation, and we finally obtain our final answer, which is omega naught by 3. So I mean, one more thing, that in exams like JEE Advanced, this question can be asked as, let me just write for you, that if average value of angular velocity is equal to omega naught by n, then n equal to dash. So you have seen blanks like this, right? So these types of questions are asked there. So anyway, I hope you enjoyed the video and you learned something from this. And also I have an update for you, that many of you are desiring to contact me through any platform. Some are wanting my phone number and other things, and some are you are commenting that give me some tips, tell me something, like that. So for you I have an update that there is a Telegram group which I will add in the description of this video, which you can join. And also I mean, you can contact me there very easily. I will be available. I will respond to all of your doubts. I mean, however possible, whatever possible rather, because you can understand that it's always not possible for me to do everything. We have a lot of work to do. But anyway, I mean, I do have whatever much is possible. So anyway, and there will be another update that there are going to be more videos this week as JEE Advanced 2024 nears. So whatever, this was the end of today's video. I hope you learned the whole concept once again, and thank you for watching, and best of luck, and prepare well for your upcoming examination.